So again, using our diagram and our prior knowledge about circles and right triangle properties, let's find some missing measurements. So here's our circle, and the center is y, so we've got circle y, and we've got some information given to us. We know the measurement for arc AC is 62 degrees. In previous lessons, we learned that when you have a chord here that's perpendicular to the radius, it's going to bisect the chord. We also know that it's going to bisect the intercepted arc for that chord as well. So if AC is 62 degrees, that means BC should also be 62 degrees. So if we add the two parts of the intercepted arc together, that would be the length for AB, which would be 124 degrees. Now if we're looking at the chord for AB, right, we talked about that length and how when the radius is perpendicular to that, it should bisect it. So AB, we said here, is 60 units. And if that radius is bisecting it, then each part would be half the amount. So half of 60 would be 30. So we know the measurement for our chord, our first segment of the chord AD being 30, as well as BD being 30. So the next piece we want to try to work on finding is our segment YD. And so this is the piece that we need here. And notice how it belongs to a radius YC. We were told that the radius for the circle was 34 units long. But YC is the entire radius, YD is a portion of the radius. So we've got to think, how can we use this information to help us find that one piece? Well, we know a circle has an infinite number of radii, so YC is not alone. Where else could we draw a radii for a circle? Well, we have a couple options. We could go from Y to B, remember center, to a point on the circumference, or Y to A. So if we draw another radius, let's see how that helps us. Now we're working with a right triangle. The radius is representing the hypotenuse. We have one leg being 30, and here's the one that's missing, YD, and that's exactly what we want to solve for. Well, when you have a right triangle and you know 2 out of the 3 sides, you could use Pythagorean theorem to find the third. So again, the sum of the 2 legs squared is equal to the hypotenuse squared. When you solve using your Pythagorean theorem, the length of YD ends up being 16 units. Now we still have to find the length of CD. Well, CD is along the radius for YC, and we already know a portion of the radius from Y to D is 16 units. Again, remember, you were given the length of the radius to start your problem. So, if we already know the length of the entire radius and a portion of it, we should be able to subtract that portion from the total to find the piece that's missing. So 34 minus 16 ends up being 18 units.